Hey, welcome back to Progressive Outcomes, guys. Spence here. In today's video, we're going to be shooting out to a little over 900 yards. And in this video, it's a little on the shorter side, but you're going to get a chance to get a few tips, a lot of learning lessons here. We're going to be covering long distance, not extreme long distance. 900, a little over 900 yards is not extreme long distance. My partner and I, my wife, and as well as a friend, we all had a chance to shoot our 7 PRCs out to about 903 yards today. And I'll go over a few things. I'm also going to be throwing a bone of some really good information that a lot of shooters, hunters, tactical guys can use, stuff I kind of train when I work with other people. I kind of created this little system here. So a lot of times we don't have a chance to set up targets properly in the terrain that which we find ourselves in sometimes, in the areas that we can safely shoot and allowed to shoot at distance, especially in a place like Hawaii here. But anyway, if you can see up here, this is the ranch that we're shooting. It's a private ranch. You get permission. Doing everything safe. I'm going to put an arrow here. We're actually looking from the shooting position, and we're going to be shooting right around this area, right around here across the valley. That was pretty steep in between here, and we didn't really have a chance to go down there and put up some steel targets. So one of the bones I'm going to throw you guys is how to definitely know the size of the target when you're shooting. As we go along here, we're also going to be touching a little bit about shooter-spotter dialogue. You're going to see that a little bit, and we're going to be able to see a little trace and give you a little tip on how to start learning how to identify trace. And in time down the road, I'll do more of an actual video or class on understanding trace a little better, or vapor trail for some of those old timers. Anyway, we got a great video ahead of us. Let's continue to watch, and I'll kind of narrate as we go along. Right here, what I call my spotter station. I got my binos, my LRF binos up there. It's Kilo 10s. It's using AB ballistics. I got the AB ballistics quantums, and then my cell phone. Unfortunately, the sun was hitting it, and it's kind of dirty screen. I didn't get a chance to clean the screen. You can't see the readouts on there. And also to the right of that is my Garmin wind meter. Anyways, because you do have to get atmospheric conditions, earth-based effects, and everything else to make long-range shots. And I can go over that kind of stuff too a little later. But you'll pick up some small tips here and there. As we move forward, I should be up first, taking the shot, and we're going to be moving into that. So that's the target that we're looking at right now, and that's me on the ground. So once we got kind of zeroed in, making sure we checked our zero and our dope, we chose a target, basically rocks. And I know all of you out there who have tried it, or you're hunting or had a chance to get up to the great outdoors, we all killed a few rocks ourselves. I'm sure we have. But anyway, a lot of the times when you're doing these long-range precision shooting, you may choose a rock, quote unquote, but do you really know the size of the rock? Because in precision shooting, to really collect your data correctly and to true yourself, you kind of have to know the size of the target in which you're shooting. So that way you can judge your impacts and your accuracy and everything else. That's either common knowledge or knowledge that you kind of need to be aware of. So some tips coming up. But in this particular sequence, as we go forward, you're going to see me taking a shot. You're going to see my partner Sean and I. You're going to hear us from taking a shot on the ground to moving into the camera and the spotting scope setup, where you see the shot going into the target, and also hearing the dialogue that we created. So pay attention to these little things. It's a baseline. We always have room for improvement. My partner and I, Sean, as well, but I think we do a pretty good job, and so you can kind of pick up some tips on that. Okay, shooter ready.
Spotter ready. There you go. Impact.
So as you overheard that, we already kind of dialed in. We had some corrections come in, and we shot. So you're going to see a slow motion video right after this. And as we're looking at this, let's continue going with this. Okay, slow-mo replay. I want you guys to look up on the 9:30, 10 o'clock, in between 9:30 and 10 area of the screen. And when the shot does go, it's in slow-mo. So you start seeing the shot come up in the area right around there. It is. Boom, right into the target there. Boom. Okay. So that's, a little bit of a scene trace. What you want to always do is basically, when you're looking for trace when you take a shot, one, we were not in the best position to be spotting. The spotting scope and the camera was located literally maybe 10 feet away from me to the right, which that is not ideal to read trace. As people who understand how to read trace and you want to get good at it, the best position to be is literally right behind the shooter, right above the shooter. You see when I'm doing that prone with the legs out and the feet down, kind of the duck stance or whatever they call it, position, excuse me. You want to be right up in between the legs, and you want to be right over the shooter as best as you can. That's where you're going to have the best chance of picking up trace. Also, more importantly, if you're going to be spotting, when you're behind the shooter in that line of trajectory and everything else, your correction calls are going to be more accurate. So think about it. If you're 10 feet off to the right or left or whatever, or even a foot or two off to the left, you're still looking at the target at an angle in comparison to where the shooter's shooting from. So when you're looking through your mills, you may be, and a lot of times you could be, off on your calls. So bear that in mind as you're spotting. Rule one, try to always get right behind the shooter when you're spotting, especially if you're going to make, wind corrections or any type of impact correction for the shooter. All right, this is a little bone I'm going to throw you guys. As I mentioned earlier, talking about to be able to measure things, and you need to know the size of the target. So this is a more up close still photo of the target in which we shoot, the rock that we're shooting. And basically the target area, as I measured it out and what we chose on this particular rock face, basically 32 inches wide and 32 inches tall. Now, how did you come up with that, Spence? Well, simple. I have a method, a mathematical solution method by utilizing your reticles and your milling tools or your range estimation tools. And this is basically what this is, somewhat in reverse. Range E is what we used to romantically call it, or range estimation. Is basically using the tools in which you have, because basically your milling reticle, and even an MOA reticle at times, is a measuring tool. You guys got to look at your reticle as a ruler. Okay, so obviously we're on first focal plane mills, and that's what I've always been, and I'm a believer in that. But I will have some solutions for the MOA guys as well. Anyway, as we measured here, you can see on the screen is that we have a TMR reticle on there, and basically I measured 1 mil at 903 yards widthwise across, and 1 mil vertical. And what that gives us is a target area of about 32 inches square. Now, when we made our initial impact and we chose an area that we want to start focusing on, that's where you see that little white square, and it measured out through the mill system and my formula. It's about 8 inches in diameter at 903 yards. So what I'm going to do is give you the formula to do this. But you have to understand now, a couple of rules are in place here. But if you're going to be using a mill radian reticle system, basically any reticle that's in mills, and hopefully you're on a first focal plane, okay? This is on the assumption that you have a full first focal plane scope with a mill reticle. Or if you're using a spotting scope with mills, or if you have any other optic that's going to be able to provide you that setup. The formula is very simple. Because you use your LRF, you have the range to target. So as you can see here, range, multiply the size in mils, so as you mill the target, divided by 27.78 will give you the size in inches inside of that measured milled area. Or basically, whatever you measured it out, and whether the mills come out within that measurement. So for example, I'm going to use the actual, how we got our numbers up here. Example, we had 903 yards. We multiplied 1 mil and divided it by 27.78, which is a constant, to be able to get yards utilizing a mill radian system. It comes up to 32.5 inches. So that's how that works. It's pretty easy, right? So for the MOA guys, using an MOA style reticle, which, okay, most of my whole professional life and adult life I've been using mills, but I do understand how to do this, and I can use a MOA scope just as much as the next guy. I just prefer to use mills. Going back to this, so here's a formula for those of you that are using an MOA reticle system. Range in yards, whether you're a rangefinder or how you got that, multiplied by size in MOA. So let's say, whatever the MOA is that you read, and understand this is base 4 and the mills is base 10. So keep that in mind. Like coming back to this formula, same thing. The only thing you change is basically mills. You took out the mills and you put it in MOA. Okay. And now the constant changes a little bit. So you divide by 95.5 and you'll get the size of that target and whatever MOA that you measured in inches. For example, 700 yards multiplied by 3 MOA. That's how big the target size, you size the area that you wanted to shoot at, or, figure out the size of it. Divided by 95.5, the constant, and you got 22 inches. Now, guys, realize this measurement form, I actually kind of came up with it for hunters that wanted to measure moose, the moose rack. I've never hunted moose. I'm an avid hunter. I'm an avid deer hunter, but the axis deer primarily. Did some whitetail back in the days when I was in Georgia, but I did get a muley once too in my life. But other than that, I just strictly focus on deer. Nonetheless, you can use this same system because a bunch of friends of mine, now friends, through my partner Sean, he's a great guy, introduced me to his friends and we became friends. But they do a lot of hunting in Alaska. Anyway, how this came to be was they wanted to figure out how can they measure the size of I guess a bull moose is what they were asking. I believe that's what it was. And because I think you have tags, so you can only take, I believe they're probably regulated just as much as elk. I could be wrong. Never hunted them, not sure. So if I'm wrong, forgive me, guys. Nonetheless, the point being is that they wanted to figure out a way to measure to see if there's the animal they wanted to take. And so I came up with the system where it's kind of a range estimation formula in reverse in a way, but it works well. Here's some key points. If you're going to be using an MOA reticle system, most people are using a second focal plane scope. You have to remember now, because you're using the reticle as a measurement tool, that most of you should know by now that a second focal plane scope, the subtensions, basically all those little hash marks that you see within the stadia lines, stadia lines is basically your primary post to crosshairs, and you have all the little marks, ticks, boxes, whatever you have within the reticle is going to be generally speaking, your subtensions. You have to be at the zoom, if you have a zoom powered scope, at the zoom in which either the factory told you to zero or whatever zoom that you decide to zero. Because what the downside to a second focal plane is if you're not on the zoom in which you zeroed or whatever the factory told you to zero at the zoom, your subtents are not going to equal out mathematically. So unlike first focal plane reticles, is no matter what zoom you are, it's going to always read the same exact thing. Yet another benefit to first focal plane. I'm not busting on second focal plane, guys. I'm just saying that you have to. There's a lot more steps involved, a lot more math involved to be able to, whatever zoom that you're at on a second focal length scope. That being said, I just want you to be aware of it. I can teach a whole class on that later if people want it, but be aware of that. Okay, with the MOS side of the house or second focal plane. The other thing about measuring is really important. You can't be lazy about it, meaning what you have to do is make sure that your whatever optic that you're using has to be extremely steady, extremely supported, and you have to know what the subtense is, and it has to be exact markings when you use it, because that can change your answer, and it could be changing it for the negative versus the positive. Yeah. So in other words, get the most stable position you can, make sure it's consistently the same sight picture, the same exact marking point, and don't say it's good enough. Especially the longer the range you go out, you have a small error in it. Of course, we all know that deviation is going to increase, which in turn is going to represent, a bad day. So please bear that in mind. If you're going to be measuring things, make sure that you are on a tripod, or if you're going to use your scope on your rifle, make sure that you're very well supported. If you don't have those options, you're using a binos that has a reticle or a sliding scope, make sure it's supported somehow on a tree limb, or on your rucksack, or your backpack, whatever it is, and get into a stable position to do these measurements. But you will be rewarded by having that extra piece of information. I haven't really seen anybody talk about this particular way of doing things, but I hope it helps you guys. So here's a free bone for you guys to use. But going back, hope that helped. And that's basically how we got the measurement. So when we were shooting in that area, we're doing pretty good. Our 7 PRCs, both my partner Sean and I, which you're going to see Sean, my partner, take a shot. You're going to hear me on the spotting scope doing some shooter spotter dialogue. And that's a whole other class in itself. But that's kind of an important thing too. It's a very powerful tool if you can work as a team together by understanding that concept. Anyway, I don't want to hold you guys here too long on the classroom side of the house, so let's get back to our video. Here's my buddy Sean taking an excellent shot, and you can also hear our spotter shooter dialogue. Good things to pick up.
I'd say 2/10 to 3/10. I would put it in the center of the 3/10 to the 4/10. Push left. Yes, sir. Roger that. Elevation is good. So look up here, you might see trace. Bingo! Impact on target.
Impact coming in right on that. And you can always rewind it on your video to go back. When I shot, I guess the sunlight, so this is where you also understand a little tip here. I can identify sunlight and shadowing can change what you can and cannot see. But try to pick up on that. It's not something you're going to learn at a snap and overnight. It takes time to learn how to read trace. The other important thing is listen to the dialogue in which we had. So this particular shot was, we shot true, testing the winds at that distance. We have an impact, not exactly where we want it, but so that conversation, when you hear it pick up, is basically a second shot is going to be a follow-up shot with the correct correction. When we work together and trust each other, boom. So as you're looking at these impacts, both mine and as well as Sean's, if you really think about it, when you go back to that measuring point that I showed you, inside of an 8-inch diameter, or we hit, from center of that, we're talking about we're within the ballpark of maybe 2.5 inches from point A at 903 yards. And if you think about that, so when people use the term, I have a half-minute accurate gun, I have a quarter-minute accurate gun, or 1 minute, I'm sub 1 minute. If you do the math, we're under a half a minute accuracy at 900 yards, and some maybe even Sean is at 0.3, 0.4, I would say, of accuracy. Anyway, so that's kind of how we're able to do it without spending a day or breaking your butt trying to set targets in an environment where the terrain is extremely difficult and at times can be dangerous. Because you got to remember, I live on an island where there's volcanic mountains and a lot of cliffs involved, and I'm not getting any younger, but by any means. But nonetheless, that is a way you can use that particular type of measuring tool to, one, when you're shooting at, you're out and you got your tags for killing rocks, or if you're going to have that opportunity to do that, or you don't have the opportunity to set up proper targets, you can utilize the targets that's out there. And you have to basically know the size of the target in the area in which you're shooting to be able to get some accuracy and some truing done. I don't think anyone would argue it. And this is a way to circumvent some of the challenges that people may have out there to do so. The other benefit to utilizing this particular formula is, one, it teaches you how to get used to your reticle more, but more importantly, if you're a hunter, you want to measure the size of the animal, you want to measure the size of the rack in which the animal has on his head, head, whatever. It's a very good tool you can use if you can learn it, practice it, utilize what you have within your equipment. And I gave you a couple of pointers. You know, this is what you do with the MOA scopes. If you got to be aware of second focal plane and mil scopes. So if someone want to ask me what do you prefer, I'm always going to favor mils. Professionally, that's what I was using. I was brought up on that, you know, for since 1988. That's all I know how to do. I do know how to use MOA. I do know how to use second focal plane. I mean, it's just part of the game, and everything up and down in between that. But I choose first focal plane. Not that it necessarily is the best. In my head, it may be for right now. But, you know, to each his own, right? Now, if you have a duplex scope, well, I'm not going to make up anything on that. That's a personal problem, as my friend would put it. Look, if you're playing with duplexes, you know, in today's world with today's technology, I just would highly recommend upgrade your scope, because a duplex, you're not going to be able to do anything and measure it at all, really, unless you really know the actual size or the representation of that. I don't even call it a stadium line; it's more like posts to me, but you don't really have anything to mark with. So bear that in mind. Again, you know, I'm trying to be mean to you guys that have duplex scopes, but you know, you can either go mil or you can go MOA or anything with. Doesn't matter what reticle you use, but if you have any type of marking system on there to use as a ruler, please do so. It can benefit you tremendously in today's world. Other than that, guys, I hope you guys learned a few things. If you guys want to learn more about some of the pointers that we have, because to go down the summary. We touched a little bit on atmospherics, you know, with the station, but we really didn't get, you know, have anything to show on that one. Using the burst range E is what I would put it. Basically, using a formula to get the size of the target in which you're looking at by utilizing the tools in which you have available to you, by just learning different ways and a little math and some techniques, and you'll be perfectly fine, and you have another tool in your toolbox to become more of a versatile shooter. Wouldn't you agree? I would think so. A little shooter spotter dialogue right there. We also discussed your positioning on spotting. Identify a little trace. I mean, it wasn't the greatest video out there yet, and I'll get some to you when we get better quality ones, but I can help teach you all this kind of stuff. If you guys want, put it in the comment section. If there's enough comments, then definitely I'll go ahead address that in other videos to come. But anyway, guys, you know, we wanted to let you know all this information is for educational purposes only, and we just like to share. Currently, this video is not being sponsored by anybody. I haven't brought up any products. Would like to be sponsored, but, you know, down the road. But then again, you know, I say that at the same time, I'm not gonna, and I know everyone says that, this is kind of almost a cliche, that I'm not gonna bust my integrity just because somebody's giving me stuff. So I have a strict rule that, you know, most people would probably appreciate on that. Anyway, going down a rabbit hole there, which I don't want to do. I really appreciate what you guys do. If you guys like this video, you know, like and subscribe. I know that it's usually a small percentage of people who do that compared to the views, and I appreciate you guys just coming in and watching. I thank you for that. But if you think any of this information, particularly what I call the reverse range E or the size of the target, helps other people, pass it along and share it. That I'm going to kind of press on that. Why not? In our industry, what we're trying to do, iron sharpeneth iron, as they say. We help share information so we all sharpen our blades and keep sharp all the time. Keep it powder dry, as an old dude used to say. Anyway, I appreciate you coming to Progressive Outcomes. Hope you enjoyed the video. I hope you learned something. And until next time.
Spotter ready?
Shooter ready.
Send it.
See you guys later.